Welcome to Future of Data and AI. I'm your host, Raja Iqbal. My guest in the show today is Jerry Liu. Jerry is the co-founder and CEO of LlamaIndex. Welcome to the show, Jerry. Excited to have you here.
Excited to be here. Thanks for having me.
And let's actually get started with, LlamaIndex. Can you describe for a layperson? And imagine that I've only used ChatGPT. I understand how ChatGPT works. Can you describe a little bit, what does LlamaIndex do?
Yeah, I think the mission is actually pretty simple for a layperson to understand, especially if you used ChatGPT. LlamaIndex takes ChatGPT, which we all use and we all love, and allows you to use it over your own personal source of data, no matter what type of data that is, unstructured, semi-structured, structured, whether you're part of a company and you want to point it to a giant directory or drive of documents, or your own personal device. That's the whole point of LlamaIndex. So whatever data that's private to you, the ChatGPT LLMs in general are not going to understand. And so how do you build the right tooling to connect that data to LLMs? So we are developer facing in that we want to give developers the right tools to do this connection so that they can build all sorts of different types of cool applications to unlock knowledge automation.
Okay. And then ChatGPT, at least publicly, as we see the tool, it was released in November of 2022, right? And LlamaIndex was released roughly around the same time. At least, it became, when I was looking at the chronology of how when it was released. So were you working on it before ChatGPT was released already? I'm just curious.
Yeah.
APIs did exist, by the way. APIs did exist, but as a public-facing tool, it came out in November of 2022.
Yeah, I would say so. LlamaIndex, or it was called GPT Index at the time, was a personal project that was mostly designed around experimenting with the APIs that were available that OpenAI provided, which had been out for about a year or so. Like DaVinci 003 had been out for about a year. And so I thought I was actually late to the game. Because it was more just, I wanted to take the opportunity to hack around with these APIs to see what types of applications we could build with large language models. ChatGPT had not come out yet. It came out about a month or so after. And ChatGPT, that whole boom was also the reason GPT Index, LlamaIndex became very, very popular. Because I think through that releasing a public-facing interface for interacting with this AI model, it just invoked a ton of interest in this entire space from every aspect of the developer community. And that definitely led to the growth and popularity of the project itself.
Okay. And when did you actually realize that a framework like this would actually be needed? Was it at one of your previous jobs, or when did it actually happen?
Yeah, it's a good question. To be totally transparent, when it first started as a project, GPT Index or LlamaIndex was very much like a design project. I was doing it mostly for fun. I was very interested in startups. I was very interested in building a company one day. And I was also interested in a variety of problems. LLMs were just one piece of that. I've mentioned this story a few times, but this is one of the things that I was actually very interested in, back in November of 2022 or October of 2022 was actually video search over unstructured data. So if you could, obviously there's SQL for querying a structured database. And I was very interested in, more and more data will become unstructured in the future. So how do we provide good interfaces for users to search over just massive amounts of unstructured data, like images, videos? So it just seemed like a very, very hard technical problem to me. And also something that could unlock a variety of use cases for different applications. So I was actually noodling on that idea for a while. And I was just very interested. And LLMs just kind of came about as a thing where I wanted to hack on it over a weekend. Just to see, what types of challenges, opportunities there were. And as I was hacking on language models, I realized there was this fundamental limitation with language models, which is the moment you try to feed it a lot of your own information, it tends to break because it has a limited context window. You can't feed your entire repository of knowledge into it. And so I started to build some basic tooling that, I would potentially use kind of I started building some basic tooling to see if I could connect, some data from our own like enterprise corpus I was working on my previous startup at the time into DaVinci 003 to see what you could to see if it would make my life a little bit easier, right? To see if I can actually build like a Slack bot or chatbot that could understand our own data. So I did that. I tried it. It worked okay. It worked decently. And I basically decided to take some of those concepts and release it as an open source library. The open source library was intentionally not supposed to be super useful at the time. The open source library, the very early days of GPT index or LlamaIndex was this thing called like a tree index, which I basically just made up. And it was around this idea of, can you develop some abstraction to index like a large set of data and have LLMs be responsible for indexing it and also traversing it. So at the time, RAG wasn't really a thing. That keyword did not really pop up. People did not really establish the best practices for, using embedding search to index your information and then doing vector lookup, retrieval to return relevant information, put it into the context window. That whole thing didn't exist yet. So I basically, it exists as a paper bill. It just wasn't popularized in the developer community yet. So like, I think our project was one of the first that triggered, when it went out on Twitter, just like interest from the developer community, because they thought, oh, this is an interesting problem, because I think a lot of people had been thinking about similar things. And this was kind of like a novel technique towards that idea. It intentionally did not use embeddings because I, at the time, really wanted to understand just the capabilities of language models themselves and be able to organize, structure, and retrieve information. And it also didn't really work because it was a design project. And so I did this thing. It worked kind of. And then I released it on socials. And after I released it, because it generated a lot of interest from the developer community, I was inspired to keep working on it, just because it was something that, when something is getting a lot of attention, you just feel compelled to continue developing features for it. And I've talked to like other open source library creators who, when it's starting to take off, they just feel a lot of motivation to keep working on it because it's pretty fun. And about a month in, I asked myself the question, because I was still working on my previous job at the time and also trying to noodle on this other like video search idea. I thought to myself, it seems like this is still getting a decent amount of attention. I started asking myself seriously if this could actually be like a useful tool for developers and then potentially like a company. And I basically made a decision about a month in to just like pivot this thing from something that was very much like a design project that worked so okay to actually like a clean set of like interfaces for developers to use to basically just like jumpstart their LLM application. And so that pivot like led to a few decisions. Like we tried to actually build out like an entire ecosystem of just tooling, from data loaders to indexes to retrieval to all these things that are nowadays necessary to create RAG. And that decision was one of the factors that, maybe basically decided to go headfirst into turning this thing into a company.
Yeah. So now that the discussion is getting somewhat technical, so a natural question that comes to anyone's mind is, when would you use LangChain versus LlamaIndex? This is one of the common questions. I'm sure you get it all the time. So when do you use one or the other? Do they complement each other, or do they compete with each other?
Yeah, there's some decent amount of overlaps between LlamaIndex, LangChain. Actually, a lot of users that we've chatted with actually do use both in some ways. I would say, you can do pretty much whatever you want in either LlamaIndex or LangChain. LangChain is a very broad framework that does a lot of different things. Depending on your preference for the level of abstractions, though, I would say, a lot of the content and resources that we put out have been centered around stuff like RAG, and more broadly, just like how do you unlock like use cases over your data? So question answering over your data, agentic reasoning over your data. So we have a lot of depth and tutorials, as well as we were like the first to basically come up with these advanced techniques over your data. And a lot of people use, that are using both, for instance, use us for the RAG and data indexing and that piece. And then, they use LangChain if they are using LangChain for kind of like some more agentic reasoning, those types of things. That said, like, to be transparent, like there are a decent amount of overlaps, and we are also investing a decent amount of effort in just like making our framework more robust, especially and more comprehensive. But yeah, a lot of people do use both.
Okay, and then in a RAG implementation, you have it is, well, retrieval augmented generation, right? So there is this whole business around retrieval and, indexing, fine tuning your search index, chunk size optimization, and tuning the search parameters, hybrid search, creating custom embeddings. And there's this whole side around generation part of it. And then the surrounding ecosystem, your retrievers and parsers and so on. So do you focus on a very specific area within this whole RAG pipeline, or is it end-to-end?
So the framework is quite broad. It focuses on giving users both the core abstractions as well as specific modules around every stage of this pipeline. So we have modules around data loading, ingestion, transformations, embeddings, indexing, being able to put it into a variety of different storage systems, vector stores, graph stores, document stores, and then doing different types of retrieval, as well as downstream modules post-retrieval, like re-ranking, and of course, like prompt training, synthesis, orchestration, that type of stuff. So we actually, in a lot of our materials and slides, and actually our documentation is structured like this. We cover every stage of this process and tell you, here are the modules that you should use. Here are the beginner sets modules. Here is stuff you can go into if you want to get more advanced. And the goal of like a framework, right, and a framework is a little bit different than like a Python library for a specific module. But the goal of a framework is to be a little bit opinionated so that you're giving users like a reference on like how to build something. And then like in the framework, you need to set up the right set of like core abstractions, and you need to like strike a balance between customizability and being opinionated, basically. So like we intentionally want all base classes, like all modules within LlamaIndex, like the retrievers, indexes, data loaders, to be very easily customizable. So if the user has their own custom needs in any one of these components, they're able to just write logic to implement that. But they're also able to plug in this component with more off-the-shelf components if they don't want to write everything into this overall RAG pipeline or LLM application pipeline.
So based on your experience, I'm sure you work with enterprises who are trying to adopt solutions. Well, first of all, do you see a lot of enterprises adopting fine-tuning based solutions or RAG-based solutions, or do you see both happening?
Yeah, so taking a step back, I think there's maybe two predominant modes of context augmentation right now, and there's potentially a third. The two dominant modes right now are retrieval augmentation and fine-tuning. And context augmentation, by the way, is just how can I use LLMs on top of my own data? Like how can I augment LLMs with the source of data that wasn't originally in the training set? And so when we look at companies and we look at developers, most of them are doing like the RAG piece. And what is RAG? Like at a very high level, it means that you're not actually training a model anymore. You're just using it like out of the box in an inference only setting. So the parameters aren't changing, but you're basically creating like a data pipeline with the model to feed data from some source into the prompt. And that's where the retrieval augmentation piece comes in. You do retrieval from a vector database, put the context into the prompt window of a language model. This paradigm, like retrieval augmented generation, where you're using the model in an inference setting, so you're not training it, but you're just composing pieces around the language model. So like the data pipeline, as well as any sort of like prompt orchestration afterwards. This is something that most people are doing today. It is something that is much easier and accessible to developers than, for instance, than like knowing how to train an underlying model itself. And so it's also like easier and faster to get started, so that you can see results in like a few minutes if you write some code versus having to wait like hours or days for a model to actually train. The other paradigm is fine tuning. So like, you can actually fine tune a model for a variety of different purposes. And we can talk about like, fine tuning versus RAG and the benefits and trade-offs, and we can get into that discussion. I'm sure there's like a lot of different aspects. So, but like fundamentally, when you fine tune a model on a data set, you're changing the parameters of the model itself. When you think about how LLMs are trained, obviously it's the same process. Like you're updating the parameters of the model to make it better over some distribution of data that you're feeding it. And so fine tuning is just taking that process and fitting it more to a specific set of data for a given user. And that we're not seeing as much of. We're seeing that more for developers or teams with a lot of ML specialists or companies where people really understand how to train or have worked a lot with NLP before and know how to train models. It typically is a bit more for specialized use cases and something that does take a little bit longer to materialize.
Yeah, and do you see down the road RAG becoming more of a paradigm of choice for enterprises down the road, or do you see both being prevalent?
Yeah, I think RAG will continue, like versus fine tuning, will continue to be more widely adopted. The reason is just ease of use and setup and accessibility to a wider audience. And fundamentally, anything that is easier to use and just at a higher level or not higher level of abstraction, but just like accessible to more people will just be more widely adopted. I think like the concepts you need to know how to fine tune a model are much more comprehensive than the concepts you need to set up a basic RAG pipeline. And so that on its own is just going to lead to wider adoption. By the way, there is a third paradigm, by the way, is basically not really like RAG, like retrieval augmented generation. But you could make an argument, we can get into this discussion as well, where as language models, like the context window gets quite big. So like 1 million, 5 million, 10 million, then you don't really need to do any sort of retrieval augmentation. You just like do inference only. Like you just like load in your data. And then every time you want to use the model, you just like stuff everything into the prompt, right? So there's no need to set up a data pipeline. All you have to do is just like, given whatever thing you want to feed the language model, just like feed it into the language model and don't worry about setting up the pipeline beforehand.
And are you talking about more futuristic, or are there any LLMs like this that are available off the shelf that have this huge context window, maybe of course not infinite, but maybe 1 million tokens or 10 million tokens? I mean, do we have any models around at the moment?
Yeah, I mean, as of today, there's Gemini 1.5 Pro, which is leading to a lot of discussions on Twitter. Like Gemini Pro, the white paper also came out, has the 1 million context window. And of course, like I think the top Gemini model, which is not public yet, will have like a 10 million context window. And actually context windows have gone almost exponentially bigger in the past year. When we first started the project, context windows were 4,000 tokens. Then of course, Anthropic, GPT-4, like Claude 2 is 200,000, GPT-4 is 128. And then there's like Gemini Pro now with like 1 million. And so, we can have that discussion as well. I think it's a very worthwhile discussion to have, which is, where does RAG fall or what is the role of RAG in the world of like long context windows? And high level, I think there's a ton of trade-offs in either one. I think you probably will still need some sort of retrieval in any case where you have like a large enough data set, just because even a 10 million context window will not be able to index a significant amount of data. And by significant, I mean like a few hundred like megabytes or gigabytes in a way that's like always going to be performant and reliable. But for certain class of problems, and especially this is something that really appeals to companies, which is they just don't have to worry about maintaining this entire pipeline. For a certain class of problems, you can just feed everything into the prompt. It's similar to how people are using ChatGPT these days. A lot of people just use raw ChatGPT, right? Because you could just like dump stuff into the prompt and copy and paste things. And the longer the context window is, the more stuff you can just dump into the prompt. It just at once without having to set up a more sophisticated pipeline in the beginning.
Okay. And two questions that emerged from the discussion here. So one is dump everything in ChatGPT. And that's second one is, use if you have a bigger context window. So let me first expand on the dump everything in ChatGPT. For an average person, what could be the risks in dumping my data into ChatGPT? I mean, it does not come free of risks, right? So should I do it or should I not do it? Or should I do it what would be those if conditions?
I think for the average person, honestly, it doesn't matter that much. I think the people that like really have these concerns that are, in my mind, like valid from like an EV perspective, or companies that stand to lose like a significant amount of money or get sued in the event that they don't explicitly have these like concerns or guardrails on like data privacy security. And of course, there is like an enterprise version of ChatGPT, right, which does come with like a bit more guarantees. But like honestly, for the average person, I think OpenAI is not like training on or like using a lot of the data traces, right, for training. I think I might be wrong on that. But basically, like, I think for the average person, honestly, it doesn't matter. I've seen people dump like everything into ChatGPT, from like, their school prompts to like their like, yeah, like their assignments, right? To like enterprise, like just uploading arbitrary amounts of documents. I would probably be careful about uploading random things to ChatGPT that are explicitly like marked as like classified within your company, right? That's probably the one piece of advice I give. But generally speaking, people are just uploading all sorts of stuff, and ChatGPT doesn't like retain your data, right? If you upload a file or something, it's not like it stores it forever. So
Okay. And let's say an average person in the sense of an enterprise that is not up to speed. They don't quite understand how generative AI works, how GPT models they work. Is this paranoia around banning ChatGPT at enterprise? I mean, do you think it is rational, or is it just irrational to actually block your employees from using ChatGPT at work?
I think it is. I mean, I can't speak for all companies. I think in a lot of cases, it's more just due to like a lack of trust in OpenAI than due to like a deep grounded, like validated concern. That said, there are certain industries, like again, like governments or like banking, certain sectors like healthcare, where it really is very important for that data to just never leave like a server, because there's always a risk. The moment like the data leaves some sort of like air gapped environment, or leaves like some thing you built a lot of security controls around, then there's always a risk that that might be intercepted, right? Like decrypted, just somehow used in some way. And so, and like if that is used in a malicious manner, there's like huge consequences for the company. And so, like, there's obviously just a lot of valid concerns in certain sectors of corporations where, like, the alternative, right, instead of using like ChatGPT, is to try to use like a local model, right? To use a model that is co-located with the rest of your data on your on-prem server, so that the data is just never leaves the device. I think that's certainly a valid concern. I think for the majority of users, though, using ChatGPT is similar to just using any other SaaS service. And there's more and more companies moving to the cloud, like using like, putting your data on Snowflake, putting your data or using like a Salesforce, like CRM, using ChatGPT is pretty much the same thing. And for most companies, moving to the cloud is basically the trend that everybody is adopting.
Yeah, and do you think that the right access controls are there? Because some of the mature software, like if I'm using Dropbox, yes, I can use the cloud, maybe SharePoint, Snowflake, all of these examples. But I have proper access controls. Do you think the access controls in case of RAG based solutions, you take the documents, you break them down into chunks, the chunks go somewhere. I built a RAG solution that the rest of the team is using. Someone uploaded some data that others should not have access to. Do you think that the state of the art in access control is there for RAG-based solutions to be feasible in a SaaS-like setting?
Yeah, that's a good question. I think RAG, first, like, to take a step back, the fact that you're doing RAG does give you the ability to implement access controls versus fine tuning. So that actually is an inherent advantage of doing RAG versus trying to like train a model over all data if that like certain pieces of that data are gated to certain subsets of users. If you actually bake all the information into the model suites through training on it, it's almost impossible to do like proper access control. I think that's just a very hard problem that no one really wants to deal with, right? Because how do you prevent like this model from like leaking information to someone that wasn't supposed to see this information? Like, I don't know. And so what RAG actually does enable, and this is something that's very useful, is that because that data is not part of that model's training set, and instead is just fed to the model during inference time, you could basically implement some sort of software system, right, during that whole like data retrieval piece, to make sure that for a given user that's asking a question using this RAG pipeline, only the amount of like the data that user has access to is getting fed to the LLM. So the LLM itself doesn't store that data. But that data is coming from some source where you can implement proper access controls. I think there's definitely a lot of interest in this space right now. I think for a lot of users who are implementing access controls, like, it's not that different from just implementing like user auth or basically just authentication in pretty much any other web application, because a lot of RAG is just setting up like rights, IDs and stuff on your storage systems, on like the data ingestion piece. That said, I think especially since the space is still somewhat early, people are still figuring out the best practices, and vector databases themselves are also basically making improvements on how do you actually store access control data within the storage layer. So vector databases, like that whole data ingestion pipeline, like I think there's going to be more and more support to make it easier for any user to basically just add access control information throughout every stage of that data pipeline up until and including when it hits the storage system. Once that pipeline is set up, it's pretty easy for users to just use those access controls when building a RAG pipeline. Because then they can just gate the information that a given user sees when they do retrieval and feed it to a language model.
That is great. So in terms of setting up a RAG pipeline, I don't do a lot of hands-on work myself, but I'm still reasonably technical even now. So from my experience, figuring out how many chunks to break and chunk overlap, the chunk chunk augmentation, chunk size optimization, tuning of your search parameters, all of that. It's quite hard. We have seen recently some solutions they claim to be, RAG in a box type solutions. What is your take on that? I mean, do you think we will get there at some point that somehow adaptively based on the content of my documentation or my documents and the document chunks, there is some magical way of shielding me from all of this details, because an LLM application developer might spend an insane amount of time in just these optimization, and something that works for one particular set of documents may not work for a different set of documents. So do you foresee that this is going to happen eventually? And is LlamaIndex doing something along those lines?
Yeah, I mean, that's basically what we're doing. And, I think that's a great question, by the way, because I think basically what you're asking is, are users going to have to define like very custom logic at every stage of this pipeline? And that's going to continue to be true? Or are like basically best practices going to emerge so that users can kind of focus on higher level things? And then there's just going to be some higher level abstractions around the core concepts of RAG that basically can be commoditized, right? So that everybody can just use this and not have to worry about setting up logic. I think that second case is generally true for most things in software. And that no one's writing like assembly or C, or most people are not these days. Most people are writing kind of like application level code, like using, Python, TypeScript, plus a variety of other languages. And, most people are using some sort of like cloud-based service and are not like provisioning, setting up the infra themselves. And I think it's true for RAG too. And I think the reason people are doing these very custom things right now is because the best practices are still emerging, and also the technology is still trying to advance so that it keeps up. A lot of developers these days are experimenting with very, very custom things because they're still in the stage of trying to discover the capabilities of a language model and really trying to understand what things work well and what don't. So this whole thing around first, what are the stages of a RAG pipeline? You load in some data, you chunk it up. You figure out the right embedding model for each chunk. You put it into like a vector storage system. And then, you do some sort of retrieval from a storage system. And then you take the retrieved chunks, you put it into an LLM prompt. I just outlined the basic stages of what a naive RAG pipeline is. For each of these stages, a developer has a lot of decisions to make. So for instance, during data loading, if you're loading PDF, you have 10 to 20 different PDF parsers to choose from. If you're doing transformations and chunking, you have 5 to 10 different chunking strategies that, LlamaIndex potentially offers, for instance, that you can choose from. The embedding model providers, obviously there's a ton of embedding models out there. You can choose from any one of those. And so the whole point here is right now, when you're in the stage of discovery and experimentation, it's nice to try to have a lot of flexibility and options, because then, you want to really understand what things work well and what things don't. And this is especially appealing to people that are used to a lot of experimentation. So the researchers, the data scientists, these types of folks. I do think though, that for just a general, if you're an enterprise and you're a team and you want to implement a lot of applications and adopt Gen AI quickly, the value prop of having infinite flexibility is less compelling. And the reason is you want to basically deliver solutions in a shorter amount of time and not spend as much engineering resources to build something production grade. If every time you're building something new, you're completely reinventing the wheel, that's just operationally very inefficient, right? And so I think as like RAG, as like a framework and like as the underlying technology develops, inevitably best practices start to develop, like standards start to emerge for different types of use cases. We'll probably start to centralize around, for instance, like different types of parsing strategies that work well. Different types of like a much smaller set of like chunking strategies that work well. And we might not even need chunking at all, right? I can talk about that as well. But basically like a set of chunking strategies that work well, generally some embedding models that work well, as well as retrieval strategy best practices, like we're hybrid search, like re-ranking, that type of stuff. And then we'll just start to see those being abstracted away as services. And like, yeah, like I think there are a variety of companies these days that are developing like out of the box RAG solutions. I think the trick though is timing. I think if you try to develop the out of the box like RAG too early, you basically run the risk of just being of no one using it once like people figure out like better practices during the discovery phase, because it's always going to take someone a lot longer to build like a managed out of the box offering for RAG versus just building Python tooling and frameworks enabling the end developer to build that service. And so if you build it too early, you basically might just try to centralize around a set of abstractions that might change in the future, and then you'll be left behind. If you never build it though, then some service is going to come along basically saying, hey, stop getting your developers to worry about this and just use our stuff. And it generally works pretty well. And for a lot of companies, they might just use this. And that's because, like a lot of developers also don't want to spend the time having to reinvent everything every time they build an application. And they would much prefer to just use much rather just use a managed service. And so I think our goal from LlamaIndex side is actually twofold. And the open source is like a crucial part of this that will never go away. The open source will always be used for discovery of new use cases and rapid iteration. I think the framework itself is production grade, and we're going to continue to make it production grade and basically the entry point into the LLM ecosystem. Models are always evolving. There's always going to be new use cases that are emerging. And the open source framework is a great way to do discovery of these different use cases, whether it's like RAG right now or agents or anything coming up later on. As like we start to see more best practices around certain use cases emerge, right? Around, for instance, documents or like PDFs or like structured data, semi-structured data around different use cases like question answering, workflow automation, like document processing extraction, like some sort of simulations. Like as best practices emerge, we're going to start probably building a bit more managed services around pieces of that that basically centralize some of the core logic and make it easier for like enterprises, like teams, enterprise developers to just consume that as a service, instead of having to figure out all the boilerplate setting this stuff up in the first place.
Yeah. I see a lot of parallels between all of this optimization around chunk sizes, chunk overlaps, keywords, and parameters. I see a lot of parallels between this and your hyperparameter optimization in your classic machine learning models. I mean, so I'm adjusting the penalty in a linear model or number of trees or perhaps a number of iterations in a boosted or a tree or an ensemble. And, once we started getting more compute, of course, some of those limitations were overcome. Now, do you see that we will reach a point where all of this we will be able to automate, just give me the right chunk size or give me the right chunk overlap, and then what should be my hybrid search parameters? Which custom embeddings should I be using out of the choices, right? So there are some parallels, but the search space in this case, in my opinion, it's much, much bigger than, tuning of 2 or 3 different parameters that have some plausible range. What are your thoughts?
Yes. I mean, I think it will. I mean, I think that's my hot take, which we'll see if it's true. But generally speaking, people like these are parameters that you can't differentiate over, so you can't just train it through backprop. But they are hyperparameters that you can do some sort of search over. And yes, the search space is very big, but it's not like there are like approximate solutions for you to at least get something decent. I think it's actually not dissimilar from any sort of hyperparameter search in traditional machine learning, as well as like neural architecture search in deep learning. Like neural architecture search, right? By the way, for those of you who aren't familiar, is basically if you imagine a machine learning engineer building a neural network, you would go and implement it in PyTorch, right? So that you like compose the nodes, the input output matrix, the weights, and then you define the activation layers, and you basically create like an MLP yourself, right? And you could do convolution networks like RNNs, transformers, that type of stuff. And neural architecture search is basically this idea that, maybe you define like a core module as an ML engineer, but then like there's some meta optimization process that tries to create the network for you, right? So it not only tries to optimize the weights of the network, but actually tries to create the overall structure of the network that best fits this problem. There's a lot of research going into this that has gone into this in the past. I haven't really kept up with recent research. And like, there is something very powerful about this overall idea, which is basically you can optimize at higher levels of abstraction instead of a fixed architecture. And because once you have like a larger parameter space, like there's just going to be like a more globally optimal solution. And that's basically the same here with RAG. It's like you have LLMs themselves, which, are already pre-trained on large amounts of data. We optimize parameters on this data. But once you build LLMs as part of this overall software system, like a retrieval augmented generation pipeline or an agent, there are going to be pieces in there that are going to become relatively standardized, like a stack. This includes like data loading, chunking, embedding, all the things you mentioned, retrieval. And all of these are going to have parameters that aren't easily fed to some backprop algorithm. And so, yes, like either the data scientist or the machine learning engineer is going to have to go and tune all these parameters and basically have a terrible time doing so. Or there's going to be best practices that emerge. So just good defaults, I think, are actually pretty important. So that roughly speaking, if you just set this up using some like with good defaults, you won't really need to tune it. But two, like basically some button that you can just click that will just optimize this a little bit more over your data set, and it will just work over your data set. I do think that's going to be like a big, big thing in the future, because I don't think that people really enjoy this idea of having to tune everything. I think people would much rather spend time, writing any sort of custom logic that actually relates to their end use case instead of having to fiddle around with like chunk size.
And just like in the traditional machine learning hype cycle, we started seeing these auto ML tools pop up, right? Because hyperparameter tuning was not for everyone, right? So not everyone understood how to tune the hyperparameter. So I think both of us agree in this case that this is where this whole RAG business is going to converge eventually, or start moving toward that direction. And do you think that increasing the context window, it is going to make this problem more tractable or more manageable for someone who's building a RAG pipeline?
Yes. And the reason for that is that it reduces the number of parameters that you have to think about. I think, if we start getting into the discussion, I think like as models get bigger in terms of longer context and greater reasoning capabilities and lower costs, people have to make fewer decisions in terms of doing trade-offs between cost, latency, and performance. And they also have to make fewer micro data decisions. For instance, like if you have better and better 1 million context windows, which are generally going to be, you can fit like books in there, or you could fit like an entire, or like 5 to 10 SEC 10K reports in there. You no longer have to think about micro optimizations at the chunk level. It's going to be more flexible and more forgiving in terms of like the amount of stuff you can put in there, right? So you don't have to tune, specific chunk in the retrieval algorithm, which means that you basically can afford to do something more simple and still have it work very well with a larger chunk size. So I think what long context windows will and better reasoning capabilities will allow you developers to do is they can like basically reduce the number of parameters in their overall pipeline and not have to worry about certain parameters, which then makes it a lot easier to set up a system that works.
And do you think a bigger context window is always better? Because, there's no such thing as free lunch, as we keep saying. We used to say this in your traditional machine learning, right? So the more complex the model gets, it comes at some sort of cost, and hence we used to have this regularization approaches, right? So do you see, once again, I have spent quite a bit of time in traditional machine learning. So when you add more parameters, you add some sort of regularization penalty. You want to discourage complexity. So Do you see any parallels once again in terms of a bigger context window? All of us are very early in this, so I don't have any practical experience with this. But a bigger context window potentially, does it mean necessarily? My question is does it necessarily mean that it is better, right? So let's say a 16K context window or 64K context window, right? So is 64K always better than 16K?
Yeah, so that's a good question. And I think I walk back the comments from what I said in my previous response about long context windows always reducing the set of parameters that users will need to choose from. What I specifically meant around that was that if you use a long context model, then you don't have to worry about things as much in terms of chunk size, because then you could just fit entire documents into the long context model. And so certain data decisions will just go away. That said, the decision of whether to use a long context model does add to the basket of options that a user has to choose from. So for instance, from being able to pick from, say, a 1 million context model that costs $1, right, in terms of inference, and also takes like 20 seconds to respond if you fill the entire context window, versus like a 16K model, which is blazing fast, takes like, sub 1 second to give you back a response, and also is much, much cheaper. And so I think like what this means is like users now have more options to choose from, because depending on their use case, the long context model might actually work really, really well for use cases where they are willing to wait, where user latency is not like the most urgent concern, and they want to basically get holistic synthesized responses across complex sources of data. And in that case, like, and this could be the case in like legal settings or other like financial settings too, that could be the best choice for them. In other cases where users want to build, for instance, like user-facing search, you do care about stuff like latency, cost. Maybe you're serving like millions of queries per day, and users have an expectation that they get back a response within a certain amount of time. Then you probably do want to optimize for latency, cost, and then even if you could stuff an entire 1 million context window, you might not always want to. Like you might want to just like still do some sort of retrieval on more fine-grained chunks of information, so that you're able to not consume as many tokens during every inference call. So I do think in general, if you imagine some sort of like curve, right, there's some sort of like cost, like there's like a bunch of scatter plot of like the cost / latency versus performance. And generally speaking, as like cost latency goes up, like performance always goes up. And that's basically some sort of line, right? That and you can draw a bunch of like points on different models that fall within this plot. Over time, cost latency will always go down. And so this line will, basically, I don't know how like the viewer is, the listener is visualizing it, but I'm just visualizing it as like cost latency on y-axis, performance on x-axis. This overall curve will shift down. And so over time, like everything will get cheaper and faster. That said, there will always be kind of like more and more use cases where like users will still need to make these trade-offs, because in my opinion, using like the best, like the biggest context window model always will not always be the best fit for like universally for all different types of use cases.
Okay. And you emphasized a lot on cost and latency. Once again, finding parallels in your traditional machine learning, right? So there is this concept, of course, of dimensionality, right? So, you cannot have too few features, you cannot have too many features, and we can't go into the details of, do a tutorial on curves of dimensionality, but the general idea is that there is a right, that Goldilocks dilemma. There is a right, it cannot be too many, it cannot be too few. Do you think the accuracy also might take a hit if your context window is too big? Is a bigger context window, is it a cure for all problems here in terms of being able to fit? Or is there any skepticism around it?
Yeah, I think any sort of longer context window model, like I think like the curse of dimensionality, the whole thing. I mean, it's an interesting thing in machine learning where, yeah, like basically what we were seeing with LLMs these days is that you can throw in more compute and parameters generally, and then problems tend to go away. as long as you have the right architecture that allows you to scale compute. And of course, like there's issues with like raw transformers architecture, right? And I'm pretty sure no one is like at these LLM training companies is actually using just the raw architecture. They're all combining like a bag of tricks, right? Whether it's like mixture of experts, like flash attention, I have no idea. Like just there's some like secret sauce that's going on that's like optimizing beyond quadratic attention. Because like the raw transformers architecture is like n squared, right? Like if you increase the context window, like the kind of like compute like scales quadratically. But I think once you have the right architecture, it turns out for a lot of these models, you just like scale up the amount of compute and it just generally gets better. And so what happens is like, I think a lot of current problems you're seeing potentially with long context windows. I think some people did analysis with like GPT-4 128K and also like Claude 2 200K, where like there's issues with attention in the middle of the context window. So that's popularly referred to as like lost in the middle problems, where like if information is in the middle of a LLM's context window, it tends to get lost and it tends to the LLM isn't able to actually recall information there in a very precise way. That problem, I think, tends to fade away as models get bigger and better. And so even the latest like Gemini Pro, I think in that paper, it attains like 99% accuracy or like recall metrics or something like that. I forgot the precise thing. And like with a bigger context window, it actually didn't run into as many loss in the middle problems as some of the earlier models with lower context windows. And I think, whatever tricks they're using under the hood, maybe it's architecture, maybe it's compute, maybe it's a mixture of both. I think generally speaking, these models will just get bigger, better, and like have better recall within the context windows itself. So I do think any sort of problems with that today is more of a temporary state of things.
So Jenny, speaking of the possibility or the general progression, let's call it progression. This is how it has been. It's storage and compute. They have been becoming cheaper and better. So as compute becomes better and what I call the enabling technologies, they become better. We can expect the cost of training a model, the cost of owning or operating a model becoming lower. Do you see some sort of equivalent of ensemble techniques or some kind of, from classic traditional machine learning, the boosting and bagging or random forest type approaches where you have a committee of models taking over as opposed to a single model?
Yeah, I think it's very interesting. I don't know how qualified I am to talk about this on the architectural level. So like mixture of experts, right? Like, I mean, I've read the basics, but it's basically in the architectural level itself, you can scale up the number of parameters, and then you basically like at every layer, like block, you basically route through like a subset of the overall number of connections because you have a router that selects like a few experts given any sort of input. And then, scale up the number of parameters with lower compute. And so it's basically a strategy for just like, selecting subsets of this overall network that makes sense for a given inference call. You can actually do this outside the pure model architecture level too. And we've actually done this on the developer end. Like if you just use an out of the box model, you can do some sort of interesting ensembling strategy. Like, if you're building like an agent or even a RAG pipeline. An example of this is if you just combine the outputs of like a variety of different RAG pipelines with different parameters, and then you just combine the results at the end. Like, let's say, you're not actually quite sure what chunk size makes sense. And so maybe you just have like 5 different RAG pipelines, one with each different type, with each chunk size. You generate 5 different responses and you aggregate the result at the end. All right. The idea of routing itself is actually quite powerful as an abstraction and tool within LlamaIndex itself. And so, disregarding like the underlying architecture, if you're just composing LLMs with other pieces of software, you can, for instance, have a router that given of like a set of like 5 or 6 options, just like given a user query, choose to route that query to a subset of these options that are the most relevant. And then you just combine and do some sort of weighted averaging of the results at the end. And so there's certainly ways to do ensembling of like pipelines of like agent reasoning over things. And you can apply it in different settings. Another example is, for instance, like one example for tabular data. And this is pretty technical, by the way. So just for those listeners who have played around with, trying to use LLMs on top of like CSV, tabular data, SQL databases, those types of things. There's typically like two ways that you can try to query tabular data for LLMs. One is if you have a CSV, you just format it as plain text and dump it into the prompt window of a language model so that, you have a language model, you just input the entire CSV comma separated values into a prompt, and then you ask a question over it. Another is you ask the LLM to, given a user query, infer a set of like pandas operations or a SQL statement to actually run over the table. So instead of like direct prompting where you're feeding all the values of the table into the prompt, you're actually trying to infer some set of operations that you can do over the values. And so an example of like an ensemble strategy you can do is you just do both, and then you combine the results at the end. You try out like 5 different ways, like trying to do like text to SQL or text to pandas, and you try out 5 different ways of doing like direct prompting, and then you just do some averaging of the results. This idea was inspired by a recent research paper that they called this like mixed self-consistency technique. The high level idea is you just try out a bunch of things and you combine the results. So yeah, I think it's definitely a very interesting thing. And I think more people will probably find out interesting ways of ensembling, whether like a LLM inference call, a RAG pipeline, or an agent later on.
Let's now shift gears and move towards entrepreneurship. So I have a few questions for you on the entrepreneurship side. Clearly, you're a very technical CEO. And your co-founder, your CTO, actually, of course, I'm sure he's also technical. So how do you resist this temptation? Because CEO it can be a different job sometimes. Do you still contribute code? Let me start with that. Are you still contributing code to the project, or you stop writing code?
Yeah, that's a good question. I think I still try to, but definitely not every day. I think I do a little bit on the weekends, but my GitHub contributions have gone way down in the past few months. And to some extent, I think it's a good question. I don't actually know if I have the right balance of how much to contribute IC stuff versus doing other things I would imagine like a CEO would typically do. In the beginning of this project, absolutely. I was like coding every day. Like in the first few months, pretty much what really mattered was just shipping velocity and being able to build this up as quickly as possible. And so we really needed like all hands on deck and just being able to build a tool. I think we were building inherently something that was very technical. We were building developer tooling. And so it was important and actually quite important for all founders, like both founders, to be very attuned to what was going on in the open source framework, have a deep empathy for the end user just through like being able to contribute directly to the abstractions of the library and understand and develop an internal sense of what the roadmap should be like. I think over time, as the team has gone bigger, just practically due to time constraints, I've stopped being able to ship a lot of the core like abstractions in the library. And to some extent, it also probably wasn't the best like end resource allocation strategy, because the issue is if I'm doing something that's blocking a bunch of other engineers, then if I don't do it, then things won't get done. And so it's better to allocate to people with like full-time capacity to work on, for instance, like a deep refactor or like any sort of like deep engineering feature work. So I still try to. I think it's important for us to continue to remain very engaged in the developer community. But I started to more treat coding as a way of like dog fooding, like product dog fooding, as opposed to like core feature development.
Mm-hmm. And at what point do you think it's more of a philosophical question, purely from a business standpoint? That Larry Page and Sergey Brin question, right? So both of you are very technical founders. And at some point in time, you have to bring in someone from outside, right? So you have to bring in. So what are the pros and cons of being a technical CEO? And how long do you think it should continue? Philosophically, I'm not asking when do you plan to step down or anything, right? But in the life cycle of the company, I'm sure you have done this kind of soul searching, right? So I see value. I consider myself to be a technical CEO. I'm fairly technical. I'm not involved in day-to-day coding, but still I see value in this. So what is your take on that?
I think if you're building a developer tool or anything that inherently is catering to a technical audience, I would almost say it's almost a requirement to be a technical founder. I think the reason is if you're not One is you just move way slower in the beginning because the person that's doing all the heavy lifting typically is the like engineering or like the technical foundations. And the second is you just wouldn't have as much empathy for like the audience that you're trying to build for. And I think one of the things that contributed to our success was just the insane volume that we shipped in the beginning, given the small team size. And I think just being able to actually really, really deeply understand some of the problems at a very technical level, anticipate where the field is going, and also build the right tooling at the right level of abstraction. I think all that stuff really mattered, especially since on the open source side, like everything is code, right? And so your product is the code that you present to the end user for them to use. And so I do think for a lot of like, at least like I can only say, speak from experience with like infra, like dev tooling, AI tools, that type of stuff. It is actually quite important to be pretty technical in the space. I think inevitably you have to scale, right? I think it's in the beginning, it's important to probably do things that don't scale, like echoing Paul Graham's essay. Like, you want to do things that, you want to go through the process of trying to do things yourself to learn, gain an intuition for what's actually needed and who you want to hire for. So for instance, like, we've gone through the process of like the founders go through, trying to actually scope out the product roadmap, trying to iterate on like the UXs of like any sort of higher level product that we're building, going through the process of obviously like being recruiters, like being the people that hire the initial folks within the company, doing a lot of user discovery and sales as well. And so being able to like have dozens of user conversations a week, really refining how you do discovery of like pain points, issues, and then how to filter that back into your product roadmap. And then eventually, once you have a product, being able to like engage in the sales process. And so we've been doing all of that. And I think throughout these realizations, we actually realized, like, especially for a deeply technical company, what you really need in the beginning is just engineering velocity and talent. I think, and I'm sure there's other ways of doing this too. And, we're at a point where we do want to look for our first non-technical hire. So far as of the time of this podcast, we have not made one quite yet, but we are looking for one pretty soon, especially since we have an enterprise offering as well. And we're trying to scale up a lot of like BD efforts and kind of like trying to make the whole like product process more efficient. But I think it's like engineering is probably by far the most important thing in the beginning. And the engineering, the pace at which you're able to ship, and the quality of the things that you're shipping.
And did I hear you correctly? You mentioned that you're going for your first non-technical hire. Is that?
Yeah. So I think these days we're starting to look for our first non-technical hire. Yeah. And keep in mind, like it's been pretty, like a lot of people look for that either like that's part of the founding team or in the first like 5 or 10 hires. I think so. We are definitely looking into it a little bit later than others. That said, we've talked to a lot of companies equivalent companies in the industry that are like data infra, dev tooling, that type of stuff. And I think it's not super out of band. Yeah.
Okay. And so who does your marketing then? Because I love the LinkedIn post from LlamaIndex. So they are, I actually enjoy them. I read them. I learn things here and there. There are many open questions that I may have. And I figured out, this is what I was looking for. So who does it? I thought that at least you have a social media marketing team.
No, that's me and our head of dev role. Yeah.
Okay, that is wonderful. I love those posts. They are clearly, they have the technical depth, but at the same time, they are easy enough for anyone to understand what is, so for anyone who's technical enough and they want to learn, you're doing a great job there. So yeah, thanks for that.
I think if you're a developer-facing company, the best marketing people will be your engineers and developers, and it has to be founder-led too. I think a lot of like traditional marketing works well for use cases where you have like domain expertise in like certain areas, but especially in this area, the most powerful folks where you can really evangelize product, deeply understand it, and have people actually trust you is going to be the technical folks on your team.
No, I agree 100%, right? As you said, right? So if your audience is technical, they expect technical correctness and utility. You cannot post fluff and survive out there for too long. So earlier, when we started the podcast, you actually mentioned that this was your weekend, project. You worked on it for a few months, and then you suddenly decided. And it took you about 7 years. I was looking at your journey. It took you about 7 years out of college, 7 to 8 years out of college. You were part of I think you were leading the entrepreneurship club at Princeton. So at no point in time you decided you were thinking about or you wanted to do it, but you did not quite have the idea. Tell me about that journey, right? So how was it, right? So you worked for Quora, you worked for Apple, then you worked for Uber, all of these companies, Two Sigma, right? So great companies. And then you did not actually decide in between to do a startup. I mean, were you waiting for the right opportunity? What was going on?
Yeah, it's a good question. Sometimes I wonder that myself as well, because I wonder there's probably multiple paths to starting a company, and this is just one path, right? And so I can only talk about the current experience, but this isn't really prescriptive on what is exactly is best path for starting a company. By the way, I think in terms of internships, so it's Apple, Quora, Two Sigma, and in terms of full time, it was so I worked at Quora full time for a year. Did research residency and was a research scientist at Uber, ATG. So working on research for self-driving for about like 2.5 years. And I spent 2 years at my last company, which is Robust Intelligence, right? So throughout this process, yeah, I've always wanted to do a startup. I mean, I think like it was something that just inherently excited me. I think typically the reason that excited me was I tend to have a bigger aversion to just pure process oriented things and more of a passion for being able to build stuff from scratch. Right. And so I think that typically that's just something that I really enjoyed, the whole like 0 to 1 phase and being able to have like full ownership for that whole process. In terms of like actually doing it, I think like I remember throughout like college and then also during the early days of my career, I think I've always wanted to do a company. I think actually I wanted to do a company before I was interested in AI. So I was part of the entrepreneurship club at Princeton. I did all these things where I was like meeting other people that are also interested in startups. And I actually only got into machine learning my senior year really of college. So actually I got into it pretty late. I learned about like basic machine learning all the way to neural nets to like how to train them and how to do a research project on them senior year. And basically, it was kind of like two parallel and oftentimes competing interests at the time, because I knew I was interested in startups, but the people that were doing startups were mostly people that were building like tools, like B2B SaaS world. But I was also, of course, like very interested in just technical problems, like STEM stuff broadly. But like really, AI was a nice intersection of interest from like just like math, stats, and coding. And so I thought it was just cool on its own, and I wanted to learn more about it. The issue, I think, fundamentally with my career was that because I was interested in machine learning, and at the time, a lot of what like being interested in machine learning meant was that people would go and get a PhD. And it was a persistent struggle for me, which is I wanted to go deeper on research. I really wanted to understand what's going on in the machine learning world. But the PhD world just seemed very detached from the world of like building companies and startups. And so I never actually ended up going to grad school to get a degree. But, if you trace through my path, I was a machine learning engineer at Quora for my first year out of school. And then I did research afterwards at Uber. So I definitely wanted to dabble into research. But then I was always on the fence about whether or not I wanted to pursue like a full grad degree, because I was also like, eventually, it'd be really nice to take some of these ideas and try to start a company. And so to some extent, the fact that I started a company in the LLM space was really like a nice intersection, I think. And I think it was nice timing, because at this point, I think I built up a decent, portfolio and background of actually understanding machine learning at a deeply technical level. But it was also an opportunity where there was a lot of product innovation to be had on top of LLMs. And so it was a nice intersection of these two fields that up until then seemed somewhat disparate, right? And I think to me, it was just a really nice timing and opportunity to get into the right place at the right time. I think before the LLM space, there were obviously plenty of startups in the machine learning space, but there was like a lot of companies in ML ops, which is what, my previous company was primarily focused on, like monitoring, observability, evaluations, that type of stuff, as well as like kind of end-to-end training platforms. But I don't know. I think there was just like fewer opportunities for just like pure disruption than this like emerging LLM boom, where there are simultaneously both really interesting research and also really interesting companies coming out of it. So I think if I like just completely did this differently, it's possible I just never went into ML at all and just purely did the startup route. And I think if I did that, I would have started way earlier in the startup space. But I think it's because I have those two interests that it took me a little bit of time to like try to merge those two together.
And out of the companies that you work for, you met Simon at Uber. I'm assuming I saw that there's an overlap in the period that you were working there. So out of all of these companies, I mean, which one did you enjoy the most? And which one is actually, I would say, maybe a catalyst to what you're doing right now?
Yeah, I mean, I think that's I think all of them help in some way. And I think in terms of the things that probably help the most, okay, what did I learn from Quora? I think Quora was actually pretty fun. I mean, it was a machine learning job. It was my first machine learning job out of college. I think I grew a lot in terms of just understanding the space at a very general level, right? Like keep in mind, I'd only just gone into the ML space basically the year before. And so I think it was a nice intro, just springboard into a lot of things. And so it was also at a startup where like startup like setting, it was like 200 people where I've had a reasonable amount of flexibility to lead and own things. So I think it was a nice intro job. What I learned from Uber, right? Because the stuff I'm doing now has nothing to do with self-driving research. I mean, I'm sure like a lot of the ML concepts, you learn, but in terms of the content, it's not really self-driving related. I think what I learned primarily from Uber was just general ML foundations. And the second thing is grit. I think research is a tough job. I think doing anything that's related to pure AI research can be very tough. And a lot of PhDs feel this way too, where you're basically working like your butt off, right? So it's like for years, just every day trying to like come up with like new techniques. You're competing with like other research institutions, right? For having like novel ideas and trying to get accepted at these top conferences. And you're working very, very hard. Like I think people like are working on the weekends, like you're like these conference deadlines, people are just pulling all-nighters. And you really do learn grit and intensity and the like just the desire to make something succeed and push it through. And I think that's actually a pretty good mindset to have, especially as you try to start a company. Right. It's almost like irrational in a sense. If you really like research, you really like it and you're willing to sacrifice other things to just like push something forward. And then my last job, Robust Intelligence, was just, it actually taught me a bunch about like, I joined when I was like, when it was 9 or 10 people and then it grew to 40, 50. And it actually gave me a pretty good sense of just like the stuff you need to grow a company. And I think I took a lot of those skills, both in terms of management skills as well as observing how teams formed around me, to basically carrying over some of those lessons into LlamaIndex today.
Yeah, and so if you were employee number 9 or 10, it is almost that the challenges at that early stage, they are very unique, right? So someone working for Microsoft or Google or Facebook, they will never ever understand, what does it look like to work under a lot of ambiguity, a lot of constraints, right? So there is so many things that it can teach you, and it's probably good prep work for doing your own startup if you join that early in a different startup.
I agree. I think in terms of hiring that in terms of who we actually look for, actually, it is a good bonus if you've either done your own startup or have worked at a very early stage company and scaled it, because then you have the right mindset for what it takes to actually be an early stage founding engineer.
And in terms of, you mentioned that you met Simon at Uber the first time. So were you planning to do a startup right from there, right from the beginning? Hey, Simon, let's team up and do something. I mean, we coworkers often talk like this, right? So hey, let's work on this idea, or it just happened, right? So your weekend project and you call Simon up. How did it all unfold?
Yeah, I mean, it was more of the latter. I think Simon and I have been friends. I knew a lot of great people at Uber, and they were people that I highly respect. They were very intelligent. They worked very hard. And I think Simon had the nice, he was very strong technically. And I knew he was a good mentor, and I knew that he had a lot of qualities that I also probably lacked. He's more of a structured thinker. and able to think about things in a very like technical architecture type perspective and really ask the deep questions, that I think is actually a really nice counterbalance to kind of me as a founder today, where I tend to rely a bit more on like intuition and quicker feedback. And that's probably just due to a function of the fact that the open source itself is just like very fast moving. And so I think when I first started this project, I wanted to look at or find a co-founder that was technically stronger than I was. And I think it was important that, for because this is developer tooling, that the other co-founder had to be technical. And, for us to be equals, like the co-founder would have to be more technical than I am. And so I looked at a few people on the list, and then I thought of Simon, and basically called him up and said, do you want to do this? And it took a little bit of convincing, but he was very excited, and I'm very excited to have him on board as a co-founder.
That's wonderful. So we are coming toward the end of our discussion here. Let's actually talk about society a bit now. In your opinion, what do you think is the biggest risk AI, generative AI, and large language models can actually pose to us as a society? Any kind of risk that you can think of?
Yeah, I mean, I think there's a few things. I think one top of mind thing is just like, there's this whole existential concern of like AGI, like destroying humans or whatever. But I think just practically speaking, it's, there's education, like economics, like what's going to happen to like the marketplace of like workers, like whose jobs are going to be automated away, like which supplies, which job roles will just shrink in supply, right? And also, I think, probably some like security concerns too. I think I've probably thought a bit more about the education piece. I think one thing is, like at the end of the day, like these things are just helping you do things and automating thought that you used to have to do yourself. And people make arguments on whether or not like this is actually good for society. I think the pro LLM group typically says, like throughout history, there's always been like devices that have helped you like do things so you don't have to do it yourself, so you can focus on like higher level tasks. The issue is that LLMs start getting into like writing and reading and just like things that you do conceptually, like things that humans can do that like basically other animals can't do, which is like reasoning, right? And once LLMs get into reasoning, I'm not actually completely convinced by the argument that it doesn't make humans like potentially like lazier or dumber over time. Because like if you're able to just trust this thing to do things, you don't have to think critically yourself. And I can't actually imagine a world where this doesn't actually just inhibit like the like development of like human thought. And so that part I'm still kind of unsure about. Because in schools, like to be honest, literally every kid is using ChatGPT right now. And like it comes down to whether or not you're really good at using ChatGPT or whether or not you can actually like, write an essay on your own terms. Mm-hmm. And it's like then a question of, okay, is it actually good that we're becoming really reliant on this technology that we can, use it really well to like just do things without us deeply understanding the concepts? And that part I'm still not really sure how to grapple with that. It's just I still feel like it basically means that you don't have to learn as many skills, that you just get a little bit, and somehow that's just okay. So I'm still thinking about it. As you can see, it's not like a fully well-formed answer, but I'm still like on the fence about whether or not that's actually good for education.
And regarding the humans, sorry for the interruption here, right? So regarding humans becoming dumber, right? So, but devs use Stack Overflow. It doesn't make them dumber, right? So, and everyone uses Google. It doesn't make them dumber, right? So it's more about perhaps a new set of skills that people have to learn. It will make them more efficient, but still, not every dev can go and figure out the right answer from Stack Overflow, right? So it's almost, I see those parallels. It is just that maybe it has gone a notch up, but we can definitely spend a lot of time discussing this.
I think that's true, but also I think the need for doing like higher level reasoning itself might actually just go down. I'm just thinking about the humans and like, it's definitely not politically correct, but like, if you think about the humans on like Wall-E, right? Like the people, like you basically can just exist in a space where you don't really have to do much and things are just automated for you. Cause that actually is part of the promise of LLMs, where, you just kind of sit back and let this thing do stuff for you. right? And there's a world where you use that to make yourself more productive so you can do even better things, right? And then there's a world where you just like don't actually need to do those better things and you just sit back and let AI like satisfy your base human needs, right? And so I think it's kind of like I'm not actually sure where the world will evolve to. Our goal right now, for what it's worth, by the way, this is like just to make sure that people don't think LlamaIndex is just going to like make everyone dumber. Like our goal right now is to make people smarter, right? By just like making it easier for you to extract out knowledge from data so you can do stuff with it. It's not really to the point where we're just like automating away all human thoughts, but where I like to think we're trying to just abstract away some of the boilerplates of you being able to get information in the first place, which I think could totally be automated away. But I think the overall end state of LLMs, I don't know.
Yeah. And let's take the flip side of it, right? So what is the area or impact in society that you're most excited about? You think that it is going to be a positive impact?
Yeah, I mean, I think on the flip side, there's so much manual like rote work, like throughout all of the enterprise that like every company that does require quite a bit of repetition and is just honestly quite painful to do. And in general, I'm pretty excited to see AI automate the things that are just honestly like just very manual and rote, right? And I think to that, and I do think that will probably take shape. Like for instance, like any sort of process automation of like, let's say you have like some spreadsheet, you want to translate it in some format and you want to do things like send an email, those types of things. That's not really like necessarily teaching humans new skills. It's just like a task that you have to perform repetitively, like over and over again. And some sort of like process automation using LLMs. I think actually can just like make companies more efficient and also let humans do like higher level tasks, right? Like basically make everybody more efficient and be able to solve problems that only they can solve. And I think like the whole promise of like knowledge extraction and automation is that LLMs actually unlock insights over new sources of data that you couldn't unlock before. Now you can all of a sudden like connect LLMs to like your entire collection of enterprise knowledge, your like PDFs, your SQL database, and do it in a way without expending like a ton of more like engineering resources. And in that sense, it basically makes information available at everybody's fingertips way better. So the flip side of AI is that it just makes everyone a much more information rich like knowledge worker, right? So that everyone can just do any sort of like task more efficiently.
So one last question, Jerry. In terms of LlamaIndex, what is coming up in the next few months that you're really excited about, and you want me to be excited about it as well?
Yeah, I mean, we just launched Llama Cloud and Llama Parse on Tuesday, which you might know. And so we launched this past week, and we are going to, for the rest of this year, focus like half and half on open source community development. That part, again, will never go away, and staying on top of the latest LLM ecosystem and building the right tools for every developer to succeed. And then for the other half, we are going to be building out the offering for Llama Cloud and Llama Parse. So for those of you who don't know, Llama Cloud is our overall enterprise platform focused on managed parsing, ingestion, and retrieval. This is currently open in like a private beta to a select number of companies. Llama Parse is a specific piece of Llama Cloud that is actually publicly available, and it's specifically document parsing for PDFs. We think this is a core stage of any RAG pipeline. If you don't have well-formatted data from your PDF, you're not going to have any sort of good LLM results from it. And so we are making this a public standalone API that anybody can use. And of course, we're baking it into the rest of Llama Cloud. And so, generally speaking, if you're a company with a lot of like complex RAG needs over your data, we're going to be adding more document sources to Llama Parse so that you can get value out of your data sources. And per our earlier discussion, actually, on kind of like the higher level abstractions for RAG, we are focused on solving just context augmentation with Llama Cloud so that, you as a developer can stop worrying about chunk size and all these things. Just set up your data pipeline, the things you want to ingest into an LLM, connect it to your storage system using Llama Cloud, and then focus on building whatever LLM application you want to do, whether it's question answering with RAG, whether it's agents, those types of things. So we're going to be building out that platform a lot more in the next few months and hoping to make a more public release of Llama Cloud available in the next few months too.
Well, Jerry, thank you so much for your time. It was a pleasure having you.
Thanks, Raja. This is a great conversation.
Thank you.